All right. So, if an impossible event is an event with absolutely no outcome, what is a certain event?
A certain outcome.
Not a certain outcome.
More than one.
Okay? More than one, technically all of the outcomes. Okay? It has everything in it.
So all outcomes.
So, impossible is no outcomes. Certain is all outcomes. So, something like the probability of rolling a 1, 2, 3, 4, 5, or 6 on a die.
Any all the above.
Okay? It's all of the above.
Choice E.
Choice E, all of the above.
Or A.
Okay, so
Oh shoot!
we're going to go back to flipping a coin.
Oh God.
Please no.
Okay, so I flipped the coin 3 times. I've given you every way it can happen. All heads, tails first, and then heads, tails in the middle, tails on the end. Heads on the end, heads in the middle, heads up front, or it can be all 3 tails. Okay, I've given you every possible thing. E sub 1. How many ways can I toss 2 or more heads? List them for me. 2 or more heads.
HHH.
HHH.
THH. HCH.
Okay.
HHT.
THH.
HTH.
HTH.
HHT.
Or HHT. Okay? Those are all of the things that fit into that category. Tossing more than 2 heads. What falls into that one?
HHH.
HHH. Okay? That is a simple event. Only one thing happens. Tossing 2 or less heads.
THH.
THH.
HTH.
HTH.
HHT.
HHT.
TTH.
TTH.
THT.
THT.
HTT.
HTT. 2 or less heads.
So that means none too. So TT.
So
Good. That means there's absolutely none. So all tails.
I'm just gonna write 2 through the left.
Make sure you label your sample space at the top 2 through whatever, or 1 through whatever then, so you remember what it means when you say 2 through.
Okay.
Tossing no heads. What falls into that category?
TT.
TTT.
Did it?
Whoops, not H. What about tossing exactly 1 tail? HTH,
THH.
THH,
HHT.
and HHT. What about the probability of first toss being heads? What falls into that category? HHH, HHT. What else falls into this category?
HHT.
HTH
HTT.
and HTT.
Well, that sounds weird. H.
You say the word. You say a letter too many times. It doesn't sound like a letter.
Yeah.
Yeah.
H does.
Yeah. H.
It's because you say it so many times.
H, 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 H.
Does it sound
H
right?
H.
H
No,
H
it doesn't sound right either.
What about the same number of heads as tails? This is an impossible event. It can't happen. Why? Because you're tossing an odd number. So there is no way to have 2 heads and 2 tails, or just 1 head, 1 tail.
So if you toss odd numbers, it won't work. So if you toss odd numbers, it won't work.
You can never have the same number of each if you toss odd.
All right.
Tossing 3 heads or less.
3 heads away. That's all of them.
That's all of them. So this is a what event? This is a certain event,
Oh.
which means all apply. All of them fall into that category. This dude harder.
I think a
hope
coin
it
and
gets
one
hard.
and a die.
I honestly think it gets
Oh
easier.
my gosh.
I hate this part of it because there's just so much going on.
Two.
I think once we actually get into the numbers, I think it's a lot easier.
Got it? Oh, fuck.
Okay, here's our last set of sample space.
Oh Lord.
Not gonna let me do this.
They got toss his tail.
Okay.
Flip a die, one
So, we're tossing a coin and rolling a die. First, let's write our sample space. What can happen? I can toss a coin and land on
1 through 6.
heads 1 through 6. So heads 1, 2, 3, 4, 5, and 6. What else can I do?
You do tails.
Tails 1 through 6. Perfect. So I can do tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. That's my entire sample space.
Okay, so that was
Okay. That's what we get to pick from when we do the events. Okay. Event 1. They don't care about what's happening with the coin. They want your die to land on an even number. Good. H2, 4, and 6. Whoops. Keep forgetting to write H. H6, and then tails 2, 4, and 6. Again, it doesn't matter what you're doing with your coin. They've worried about your die. Event 2, the probability of a head. H is 1 through 6. 4, H5, H6. As I said, I hate this part because I think it's more confusing
These are
when
better
we
than-
start to toss numbers in it.
H1, H3,
It's too
H5.
repetitive.
Head and an odd. So H1, H3, H5. What about a tail and a prime number?
Oh, wow.
Oh, what's my prime numbers again? So I know I need a tail. Tail 3 falls. Tail 5.
7.
Can you roll a 7 on a die?
No.
No.
6.
That made it impossible.
He did. There's 2 more that fit into this category.
1.
1 and 2.
Okay, I forgot what prime is.
Remember, a prime is a number that is only divisible by 1 and itself.
Oh, yeah.
So 4 is not because it's divisible by 2.
I'm gonna make a note.
6 is not, it's divisible by 2 and 3.
Yeah,
What about a number less than 7? That's all. This is my certain event. All of my numbers are less than 7. A number less than 3.
T1,
T1,
T2,
T2,
H2.
H2,
H1.
and H1. Perfect. What about a 7 as well? That's impossible. I mean, yes, there are dies with 7 on them. However, we are only talking about a 6-sided cube.
Die.
There's one that got a whole bunch of stuff.
Oh, yeah. Bless you.
Bless you. Bless you, sir.
Bless the heck out of you.
Let's-
Bless you. Everybody's allergic to school now.
I have
We're all allergic to school.
I take shots before
Wouldn't it be weird if someone's allergic to emotions?
All right. So when they're asking for the probability of an event, you're going to see a notation, PR, and whatever's in parentheses is the probability you're trying to find. So if I want the probability of rolling a 6, you will see PR
6.
rolling a 6 or something along those lines.
Yep.
So PR stands for I want the probability. And what you want the probability of will always be in parentheses. Your probability assignment of an impossible event is a 0. It can't happen. There's nothing there. And the probability assignment of a certain event, the entire sample space, is a 1.
Okay.
So this means What is the probability of an even on a die? What's the probability of rolling an even on a die? 3 out of 6. What's the probability of an odd on a die? 3 out of 6. If I put these two together, what do I get? 1. So the probability of an entire event, if you add up all the simple things, always equals 1.
Okay.
That is something that you need to know. So here is our first example. I'm not going to do it.
So what are you doing?
How many of you watch tennis?
Nope.
Oh, your
Serena
parents watch
Williams,
tennis?
baby.
I didn't know she built.
You at least know about Serena and Venus
That's my
Williams, right?
future baby mama.
No.
She gonna
That's
beat
what?
you.
My future baby
She gonna-
mama.
That's your future baby mama.
She gonna beat
Oh,
you.
well, it's on YouTube right now. You could, post.
He gonna be whipped. It's okay. She
Wait,
a man.
wait, she-
That's a
She
man.
don't live in the United States, does she?
You gonna
That
be
don't
whipped.
mean she can't watch YouTube.
Right, just tell me like it's already.
Like, look, I love you, my future baby mama. Will you marry
You know
me?
you're
I'm
recording,
trying to
right? Put a ring on.
Whipped.
All
right.
That's a
So-
man.
We have 6 players in a tennis tournament. We've got Anna, who's a Russian female. Ivan is a Croatian male. Leighton is an Aussie male. Roger is a Swiss male. Serena is an American female. And her sister Venus is also an American female. Sample space is who is going to win the tournament. Okay, so your sample space is everybody in the tournament. We've got Anna. We've got Ivan. We've got Leighton. We've got Roger. We've got Serena. And we've got Venus. Again, your sample space is everything possible that can happen. So the sample space of a die would be 1, 2, 3, 4, 5, and 6. The sample space of a coin would be heads and tails.
Roger.
You did it right there, Miss Smith. The time where you draw scribbles, that was a good one at the end.
Yep.
Oh, thanks.
Yeah.
I try. It
least
happens
you-
sometimes.
At least you tried.
Right. That's all that matters. I try.
I'm gonna touch it for you.
That brings
Oh,
me
I
back.
try.
Show your singing talents to YouTube.
Nah. Somebody will really shut it off if I try to sing.
I hate work.
Okay,
That's
so-
that's on it.
We had a professional odds maker that came up, and it says that Anna has 0.08 probability of winning. Ivan has a 0.16, Leighton has 0.20, Roger has 0.25, and Venus has 0.16. The only person they don't tell us about is Serena. How do I find Serena?
Well, we already know she's 100.
Yeah.
How you gonna add in the box?
Okay. How do I find Serena?
I got no idea.
When you add all up, that's a
Add all of them up and do what?
divide.
No.
One.
Subtract it from 1. Remember, the probability of everything put together is a 1. So if I add all these up, I get the probability of Serena not winning. Okay, so if I add all of them up, I get the probability of Serena not winning. This is going to be the probability of not Serena. What do we get for a probability of not Serena? 0.85. So if that's the probability of not Serena, and the entire probability is a 1, we subtract the 2, and this becomes the probability of
Sheesh.
Serena.
What she got?
Which somebody has just said 0.15. So Serena
Baba, sir.
actually isn't going to win if you go by the probability. Who's going to win?
Roger.
Roger.
Roger Rabbit.
Roger Rabbit.
Who's Frank? He ain't. He can't.
Bro, Serena wins
You,
every
you
game.
think Serena wins? She
Hold on,
feels
hold
like
on,
a
hold on,
dude.
hold on. Please.
She will beat you.
Yeah, I bet you if you try to steal from her in the dark alley, it's over.
I would never ever attempt that
That's
in
why I
life.
said. That's why I said Chris gonna get whipped.
She'd probably kill us.
Boy, she's a bird.
She,
She's a bird. Right, that's right. She's Floyd back
she
there.
built like a car.
Who was I fighting? Serena.
She gonna break the ropes. And
I'm like, Serena, Tommy was in bed.
What?
You wouldn't try to fight any kid.
What?
And then she likes that when you show you.
Okay.
Whip.
So, I want to find the probability of an American winning. Who's my American? Who's my American? Serena and Venus. So, to find the probability of an American winning, we add their probabilities together. What's my probability of Serena?
0.15.
0.15, and Venus? 0.16. So together they have a probability of
Point something.
0.31 is the probability that you will see an American win the tournament. What about the probability of a male? Who's my males? Roger.
Ivan.
Ivan.
Layton.
Layton.
Whoa, you gotta add all the A's in there.
Okay, so Roger. What is his probability?
Roger is 20.25.
0.25 plus Ivan.
It's 0.16.
0.16 plus Layton.
0.20.
0.20. That gives us a total probability of a male winning.
Women, that's 20, that's 45, that's 56. I mean,
Who that might make the change?
He's at 45.
What about the probability of an American male winning? Impossible. I don't have any American males. All of my Americans are females. What about the probability of a European winning?
We got a European in there.
I don't know, I couldn't tell you.
Russia.
And
Okay, so that means Anna,
what is Swiss?
Ivan.
Ivan. There's one more European. Roger. Okay. Anna, Ivan, and Roger are all Europeans. So 0.08. Ivan is 16. And Roger is 0.25, which means a European has a probability of what? 0.49. Perfect.
149?
Well,
Oh, 0.49.
the male got it.
And finally, the probability of a female winning.
Anna, Venus, and Serena. Oh, baby.
Anna,
Venus,
Venus,
Serena.
and Serena. So that's 0.08 plus Venus was what? 0.16?
Yep.
And Serena was 0.15. So that gives us a total of what? 0.39. Okay, notice something.
No, so we're gonna win. I mean,
Female and male.
we're gonna win.
They add up to what? 1. Okay? You can either have a male or a female win. They should add up to 1.
American European.
Okay? All right. Probability space. Okay, so this is basically telling us that your probability of some event should always be between 0 and 1. It should always be a decimal or a fraction. We're going to leave them in decimal now. Again, the probability of an empty event is 0. They show empty events by those 2 squiggly lines without anything in between them.
What's for you?
Okay, the little squiggly fancy things that I can't draw, but the little, those things.
There you go. Well,
I
yeah.
I can't.
See, now look, the last
Either
one
that,
always
or
does.
sometimes they will put a 0 with a dash through it in there
The last one
Okay.
you did was always good.
to denote nothing. A certain event will always be written as probability, and they'll have the S in there to stand for the entire sample space. And again, that is 1. When you add all these up, they should always equal 1. Okay, this is going to be very important. And that will help us solve these last, I think we have 5 questions in this section. Okay, that's going to help us with this. So, this tells me I have probability space. I've got event 1, 2, 3, 4, and 5. Or I'm sorry, 1, 2, 3, and 4. That's what these stand for. Each one of those is a probability. If the outcomes are equally likely, what is the probability of each one of these events? Why?
What is that?
That's like a
Okay,
mutual Q or something like that.
it's kind of like a cursive O.
That was like a mutual.
Okay. So think about it. If I have a probability of 1, and I'm splitting that between 4 different sections, that's 0.25. So each one of these will have a probability of 0.25. Okay. In the next one, they give us the probability of 1, 2, and 3. They want us to find the probability of 4. Remember, the total has to equal 1. So what can I do here? Add them together and subtract them from 1. Another way we can do this, let's say this is x. This is something we don't know. So the probability of 1, 2, 3, and 4 put together should equal 1. Okay, it's the same thing as adding them all together and
So you just add the
subtracting
first-
from 1.
So you just add the first numbers basically. Right? First numbers to reach.
So 0.3, 0.25, and 0.17 come out to give me what? 0.52? Point what? 72. Okay, so 0.72 plus my unknown should equal 1. So we subtract off 0.72 from both sides, and x equals 0.28. Okay? This is why I told you to set this one up as an equation. Because as it gets more difficult, it's easier to set it up as an equation and solve. Now they tell us that 1 is 0.18, 2 is 0.12, and 3 and 4 are equal to each other. So let's make one of our unknowns x. If 3 is x and 3 equals 4, what is 4? X. And remember, all 4 of these added up should equal 1. So 0.18 plus 0.12 plus x plus another x should equal 1. Oh, here's stepping back to math 1. Combine like terms.
It's
No.
2x.
That's 2x. What do I get when I combine this?
0.30.
0.30 or 0.3 equals 2x. Now what?
Wait a minute. Subtract 0.3.
Subtract 0.3 from both sides. So 2x equals
0.7.
0.7.
And then you, wait a minute, let me do it. 0.7, yeah, you divide by 2.
So x equals 0.35. Okay? Probability of 1 is 0.18. Probability of 2 is 0.22. Probability of 3 is double the probability of 4.
2x.
Okay? So, no, not x squared.
2x. No, I moved 2x.
2x. Which one's 2x?
4.
3 is
Wait, no.
2x. 3 is double what 4 is. So we're going to make 4x. Remember, always assign your lowest first. 4 is my lowest. 3 is double that. So 3 is 2 times that. And again, 1 plus 2 plus 3 plus 4 should always equal 1. So now we combine like terms and I get 0.4 plus, what are my x's when I put them together?
3x
3x,
equals 1
okay,
minus 0.4.
minus 0.4.
That
3x equals 0.6.
0.6, 3x equals, and you divide. Let me do that real quick.
Why are you saying it like it's a food tutorial?
That is 0.2.
0.2.
Everybody is like you trying to talk about this.
All right. Let's see what this last one does for you. Woo! Here we go.
Now,
Oh gosh, so they got 2x for the first.
This time they don't tell us crap.
Dang!
Okay.
Double.
P1 is double of P2.
Oh, no.
so 2x.
P2, 3, and 4 are equal.
So
Okay,
2x.
stop. P1 is double P2. What is the least? P2. So assign it a variable. If P2 is X, what does that make P1?
2x.
If P2 equals P3, which equals P4, what's 3 and 4?
X, X, X.
X and X. So 2X plus X plus X plus X
6x.
equals 1. Not 6X.
2, 3, 4, 5, 6.
You got too many X's in there. This is P2 and this is also P2. Don't write a double X there.
Okay.
5x.
5x.
So 5X equals 1,
Divided by 5.
which means
0.2.
X equals
0.2.
0.2. Okay, stop there. What are all of the probabilities? This gives me X. So what's the probability of event 1? 0.4. It's double it. What's the probability of 2? 0.2, because 2 is X. What's the probability of 3? 0.2. And what's the probability of 4? 0.2. Fantastic.
Yeah, we're done.
You just completed an entire section
Dang,
One day.
in one day. And not even, yeah, right, before lunch.
Are we gonna, so we're gonna do another chapter, another,
Please, let's go ahead and do another chapter, man.
after lunch. Can't we just do it after lunch?
Yeah, let's just
We
do
can go ahead and
it.
start. It's not time to go yet.
Right, we can probably get the front page done.
Yeah,
And then walk
Brianna.
away.
That's not my name. Don't call me that.
Brianna.
That's not my name either.
Brianna.
There you go.
Okay.
I'd like to get through 15.5 part 1 today, and we can do 15.5 part 2 and odds tomorrow.
Can we do this after lunch?
Okay. We can probably get this front side done now. That way, when we come back from lunch, I have like, I think 4 or 5 examples, and then you guys can work on practice problems.
Yay.
So, equal probability spaces. A probability space where each simple event has equal probability of occurring, which means all outcomes are equally likely. The probability is a ratio, which is why it's a fraction. Remember, a fraction is a ratio, 1 to 6, 1 out of 6. The size of it happening versus the size of everything. So, example 1, I have 12 boys and 15 girls in a class. What is the probability that I call a boy out of the class?
12 out of 15.
Oh.
It's those ratios. Of the class.
Well, that's what he said.
So 12 out of 27. Remember, you don't just have boys in the class or just girls in the class. The total in my class is 27 kids. Okay? It just happens I'm picking a boy out of the class. So if I said, what's the probability of pulling a girl out of the class?
Same. Wait, no.
15 out of 27. I have more girls than boys. A die being tossed once. What's the probability of rolling a 1?
1 out of 6.
1 out of 6. I have 6 numbers available, and there's only one of them that is a 1. What is the probability of rolling an even number?
3 out of 6. Would it be 1/2?
3 out of 6 or 1/2. A 4-character password is made from numbers and letters,
Oh,
which are
God.
not case sensitive. What's the probability of a password being all numbers? Remember, you've got 4 spaces. Each space has has how many choices? 10. I'm doing all numbers. So 10 times 10
10,000.
times 10, or 10 to the 4th power, which is 10,000. Okay, but Once you got to A, it says it's just all numbers. It says what's the probability of all numbers? Okay. Part B says I want to begin with 2 letters
What do we,
and end with 2 numbers.
what do we, 26, 26, 10, 10.
26, 26, 10, 10. So 26 to the second times 10 to the second. Either way you want to write it. Oops, 600. Okay, stop there for a second. Because what you just came up with is the top part of the fraction. We're doing probability now. We now need to come up with the bottom part. You figured out the probability of this event. Ethan said, wait, I thought that said letters or numbers. And it does. Okay, so what's the probability of each one of these being a letter or a number? 36 to the 4th. So you need to divide each one of these by 36 to the 4th power to get the probability. You found the simple event that goes on the top. To get the probability, you have to divide by the entire thing, which is numbers and letters, which are not case sensitive. So this should actually come out to be 0.00595. Remember, we said probability has to be between 0 and 1. 10,000 is not between 0 and 1. So that tells me right there that's wrong. Same thing over here. 67,600 is not between 0 and 1. So that should tell me right there it's wrong. This should come out to be 0.04025, and this should be 0.0059. The last thing we're going to talk about before you head to lunch is a compliment.
Compliment, baby. Compliment me.
Not like that.
Not as in, Zach, you're looking mighty pretty today. Compliment as in opposite. Okay? So, if I say, while you're writing, if I say something like, I want to pull a black card out of the deck, what's the opposite of that? What else is in a deck? Not red card. Okay, so the opposite of a black card is a red card. Why do y'all gotta jump to race? Right, white card. Okay. So my event is picking a black card. What's the opposite of a black card?
Red card.
Red card. Opposite of picking a heart.
Hold up. Oh.
What is not a heart? Diamond, club, and spade. Okay, a compliment is everything that my situation is not. Okay, it's kind of like the opposite. So, 4-question true or false with at most 2 true. What does that mean first? At most 2 true. So that's 2.
Does that have to be true?
2 or less, which is 2, 1, and 0. That is this event. What is opposite of that? At least 2, which is 2, 3, and 4.
So that's 3.
Okay. At most 2 means 2 or less. 2 and under. Okay. You want to go, actually, this should probably be more than 2. So it doesn't include 2.
It was before. Even these are got confused.
Okay, I'm in.
Yeah. This should be more than 2. It shouldn't even include 2. It should include everything that this doesn't. So because this is 2, 1, and 0, this has to be more than 2, which is 3 and 4. Okay, so think about what it's asking you and then go the opposite route. Flipping a coin twice and getting 1 tail. What is different than getting 1 tail? Getting 2 tails or in terms of tails.
Oh, in terms of tails.
Two tails. No,
So
one
I can
tail.
get 2 tails or no tails. Okay, don't switch it and talk about heads. Keep it in terms of what they're talking about. If I get 1 tail, different than that is 2 tails or no tails. Flipping a coin 3 times and getting all heads.
No heads.
So I can get no heads,
1,
1,
2, and 3. Alright, that's 3.
2, and stop there because that is 3. And the last one, rolling a die 6 times and getting at least 4 even digits.
So at most
What does at least mean?
4.
4 or more. So what is opposite than 4 and more?
4 at that.
Less.
No, not 4. Don't include 4.
3, 2, 1.
So less than 4.
So 3.
Okay.
I'm trying to say 6.
At least 4 means 4, 5, and 6. So we want opposite of that, which is 3, 2, 1, and 0. Okay. So that's all less than 4. Or you can say it as 3 and less.
A dice is 0? Yeah, how do you get 0?
It's talking about even digits. You can get 0 even digits. You can roll it and get 1, 1, 1, 1, 1, where you have no even numbers. It's not talking about the number on the die. Okay.
Already done.
Okay. Question. You're confused? It's okay. We can do more. We can do plenty
Just
more.
hope at least miss.
That's fine.
Right.
We will start with this when we come back from lunch.
Let's go for lunch.
Hey, bro, we have a good stuff all